Datacenter Clarity LC includes a browser-based application that provides much of its core functionality in a light, intuitive, and portable version to facilitate deployment, use, and accessibility. The web client is entirely web-based, HTML5, which makes it cross-browser and cross-device compatible, including tablets, for maximum accessibility and ease of use. It features an intuitive interface for 2D and 3D navigation, asset and usage information directly within the 3D model, real-time temperature monitoring and heat map visualization, network connections and cable management, management of asset and equipment database, user access management, management of Datacenter Clarity LC configuration, and centralized access to all Datacenter Clarity LC logs. Asset search within Datacenter Clarity LC can be done directly from the 3D models. Go to the Asset Management toolbar where you'll find Asset Search and can enter the asset ID, name, category, and type. You can filter by status or serial number, or you can even directly enter the host ID in the search field. In the search results, when you click directly on the screen, you'll see the asset highlighted in the model, and you can navigate it very quickly. Also from this screen, you can even edit any of the attributes of the specific asset for which you just searched, including changing the U spot if needed. Datacenter Clarity LC offers a rich 4D reporting toolkit with out-of-the-box reports that can be utilized for planning and operational purposes, and which are a key to operating a data center at its maximum efficiency. Let's look at an example. First, let's look at the U-Space Utilization Report by activating it. With regards to rack utilization, directly on the 3D model, we can see a range of 0 to 60% use of space. We can navigate very effectively from the top view to an isometric view to see additional details. We can highlight, let's say, just the 0 to 60% utilization rate and then visually isolate the space that's available to place additional assets. Another key parameter to look at is the real-time power consumption of each of the servers. You can accomplish this by probing into each piece of IT equipment and individually displaying its power consumption. Here you see the scale of 0 to 200 watts. There are 277 objects drawing greater than 1,000 watts. Let's look at another example. We can visually separate the assets that are consuming the most power, see where they are located, and even make changes to the capacity of the equipment feeding these servers, or even optimize the servers themselves. We can aggregate any of this data at the rack level. The total power can be summed up automatically in real time to see how much power is being consumed by the entire rack for all of the equipment in the aggregation. It's the same approach for asset weights. As you load the rack, the weight of each component is added and stored in Datacenter Clarity LC. You can see here some of the racks that have over 600 kilograms. This may become valuable information for the data center operators when considering whether to move a rack or when being mindful of weight limitations. You can look at asset ID, temperature, status, category, age, date information, numbering information, real-time information, or even business or client information, which can be overlaid on the 3D model. Having the ability to layer any of these rich data sets over three-dimensional images truly demonstrates the value of what we call 4D reporting. Increase in demand, consolidation projects, and simple day-to-day changes all call for the creation of new assets within a data center. With Datacenter Clarity LC, these assets can be created directly inside the 3D model. Let's look at the power consumed by each of the racks. For this, we want to isolate the group of racks where the least amount of power is consumed. As we can see, there are quite a few racks here we can pick from. We can zoom in. Let's pick this rack. Directly from the interface, we can go into Asset Management and select Create Asset. As we get the Create Asset dialog box, we can select specific properties to customize the characteristics of the new asset. In this example, we can pick any Fujitsu server model, let's say an RX 300 in this case. As you can see here, we have many vendors and many different models that we support. We can look at Host ID. We can look at various components. Then we can select this rack where we've identified that we have a very small amount of power being consumed at this rack level. Let's say we want to put it at U spot 37. We can click OK, and the asset will be created and placed in the U37 spot. You can immediately see the asset being added inside Datacenter Clarity. We can automatically discover resources in the Asset Management window within Datacenter Clarity LC. We can do so through an IP address range, a subnet, subnet with prefix, single device, or the entire database. In this case, let's use an IP range. We previously entered an IP range to query. The scan function will ping or scan the IP of the many devices of the various networks that are available. In this case, we have two assets that have normal responses. Indeed, the ping response from the network is valid. The host name's information is provided, and the status of these two assets is operational. We also have three unknown assets, meaning that physically these devices exist and are responding to the network ping, but are not in fact in the Datacenter Clarity database. In this case, we can add these three assets into the database in their proper locations. To do so, the first step is typically to export these assets, then set in place the suitable workflow to track the progress and completion of the task of adding these assets in Datacenter Clarity LC. We can perform an asset move directly from the interface. We simply zoom in on an area of the data center where we want to make a change. We select the asset. Then for rack selection, we can change the rack location. Here we will go and associate to U38 of that rack. Upon completing the changes, we can now change its status to operational because we have enabled that asset in its new location. As you will see here, it will disappear from the original rack in 3D and moved in 3 dimensions to the second rack that we've selected. As you can see, moving assets within Datacenter Clarity LC is simple and straightforward. Within the 3D environment of Datacenter Clarity LC, we can search for electrical connections. View and trace the upstream and downstream connections on the floor. Simply by clicking on the 3D asset, in this case the floor-mounted PDU, we can visually distinguish what are the upstream and downstream devices that are connected to these floor-mounted PDUs. We also can view the various upstream assets in table format. As a result, we can determine precisely what is feeding an electrical component, and can also see the entire list of IT devices that are being supplied by this electrical component. For troubleshooting purposes, this is extremely valuable information. Understanding the upstream and downstream electrical links that exist between the physical assets is imperative to the operational performance of the data center. Data center operators will find value in the ability to visually grasp the upstream and downstream electrical interconnections and to have the real-time data juxtaposed on that same 2D drawing. A Datacenter Clarity LC 2D diagram allows for quicker and better analysis of the overall operational environment. Different 2D diagrams are created directly from the 3D model of Datacenter Clarity LC. For example, as you can see here, a person can load a previous view of that with which he or she prefers to work. Let's say someone wishes to analyze a UPS, which has shown symptoms of degrading operating conditions. To achieve this, you can do useful data mining by viewing the real-time and historical data trends. For example, latest power values, latest current values, and what-if scenarios. For this, one can simulate an increase in power demand in order to see the impact on the behavior of the UPS, the various thresholds it will attain in that condition, and whether the UPS will stay green or yellow or move to red for an alarm stage. The alarms are in real time, and the data center operators are informed if assets are either in warning mode or error mode. Here, UPS 2 and UPS 1 are both under a warning indication. As Datacenter Clarity LC constantly monitors the operating conditions of these two UPSs, it can detect that suddenly UPS 1 goes into alarm. Data center personnel are visually alerted of this by the associated line in the 2D diagram also changing to red. From there, one can go into the Info tab and view key data parameters for UPS 1, such as maximum current and the derated current. Let's explore further how this 2D diagram can be used. Let's say a person selects crack under number 3. He or she can further investigate by looking at the real-time information of that device via a dashboard fabricated specifically for crack units. Data center personnel can drill down to pull information on what happened over the course of the last 2 hours of operation of this crack unit. They can look at supply and return, temperature and humidity controls, and other sensors that may be connected. The global status button is green and normal. Further down the screen, the data center personnel can see the reading of the fan rate cooling, the state of free cooling, heating conditions, and the humidifying capacity. Operations personnel have a wide range of data sets to monitor, both in real time and on an historical basis. They can go back a month, a quarter, or a year by selecting the appropriate tab on the screen. Company executives need actionable, high-level, overarching information to profitably run their organizations. The information needs to be aggregated, complete, and trustworthy. Datacenter Clarity LC delivers that value, and it can scale from one single data center to dozens of them being monitored from one central location if desired. Datacenter Clarity LC offers an executive-level, web-based dashboard with information that really matters to executives. In this case, you have navigational maps with 2 zones, the Americas and Europe, capacity planning information. In the lower right corner, you can see key performance indicators for the various sites. Just to the left, you can view the number and type of assets that are being managed. Let's go back to the radar graph showing information for the Americas and Europe. We can see the capacity parameters overlaid for both zones. The scale goes from 0 to 100% capacity. In this case, 80% capacity is used by the Americas versus about 36% capacity in Europe. This visual allows you to quickly determine where you have space for power, U-space, floor space, cooling, and IT devices. You can drill down further into power capacity and view the capacity used, the maximum available capacity, and the number of days left before you run out of power. The same is true for U-space. You can see the U-space used, the number of U-space currently in use, the total capacity you have, the number of days left, and more for floor space capacity, cooling, IT, or even water. In the case when relative parameters are not monitored, you simply get a not monitored view. In order to see the data unique to a single site, you can navigate and drill down further through each specific country and its specific sites. Here, if we see a PUE of 1.5, we might want to understand the PUE of that specific site. Using this Datacenter Clarity LC dashboard feature, you are able to view real-time information for that specific component. If you're interested in seeing the total power usage, you can view data by a weekly, monthly, quarterly, or even an annual basis. Directly from the Asset Management menu, you have access to a web-based dashboard for smarter, top-level decision-making. For each specific device-level asset, Datacenter Clarity LC offers trending and real-time information dashboards. Let's begin with the HVAC dashboard. If we look at a crack unit, we have a web-based link that will provide all the information for the unit or system. In this case, we can look at the fans and see the percentage of on and off times for these fans. You can see right now that it's at 68.38%. You can look at the cooling information. You can look at dehumidifying information. You can also see the various temperatures, temperature gauges, or humidity levels for the asset on the supply and return of your crack unit. These are very simple yet powerful real-time dashboards. You can drill down from 1 hour to 6 hours, 12 hours a day, a week, a month, a quarter, or even a year. You can see various components and always go back, and you can drill down and look at very specific data of interest at any point in time. This dashboard was for the crack unit. You can do the same if you look at the power meter. You can view the three-phase power information for your data center. In this case, we look at the three-phase information for that specific power meter. You can look at the currents, the voltage, and all of the electrical information. You also have the power data and the phase information all in real time, as well as energy data, active energy, and reactive energy. Power quality is very important in most data centers to make sure the quality of the power is consistent and so on. Here is the same type of dashboard, but different types of data are being displayed. We can have the same type of dashboard as well for the IT equipment. In this case, if we look at a data storage device, we are going to look at two types of data that we can retrieve from this IT device, including temperature and power. You can look at, let's say, the temperature over time. Again, it's the same concept. You can drag the mouse and understand at different times of the year. You can zoom in, zoom out, or just look at the last hour, perhaps to see how the temperature has been steadily increasing for that IT component. You can take proactive measures knowing this information. These are only 3 of a multitude of real-time information dashboards supplied within Datacenter Clarity LC. Integrating with over 400 different communication protocols that you can leverage data sets from essentially all of the devices and systems in your data center. Real-time information from power devices, fire safety systems, servers, and much more are pooled into one common database. Directly within the Data Center Asset Management, you are able to load CFD model results. You can look at cross-sections of airflow and air temperature within the entire data center. In this case, we can see a cross-section of the air temperature, whether it's here in this 2D perspective or at waist level through the entire data center. The same is valid for a specific criteria area where we've isolated a hotspot. The hotspot is behind this rack. We can easily slide through, rotate, pan, and zoom to isolate the area on which we need to focus. Then we can make the appropriate server changes at a convenient predetermined time before a failure occurs. This illustrates how downtime can be avoided and how energy costs can be tackled with a DCIM solution from Siemens.